Hello. Today we're going to be talking about the speculative evolution of the hyperfeline. This is a hypothetical biomechanical analysis of hyperfeline, a speculative post-leopard lineage that emerged during a global freeze known as the Eternal Winter. The core premise of the study is that extreme environmental catalysts forced felines to transcend their normal physiological limitations to ensure evolutionary viability. Subsequently, this presentation will analyze the structural mechanics, kinematics, and ecological impacts of this apex predator. Evolutionary lineage. To contextualize their evolutionary history, the hyperfeline lineage diverged from Pantheroparidus, the modern leopard, roughly 50,000 years into the perpetual snow event. While larger cats like lions and tigers collapsed due to insufficient thermoregulation and acute prey scarcity, the leopard's unique ecological versatility allowed it to survive under relentless selection parameters. This lineage shifted its morphology from an adaptable generalist to a super-specialized apex predator engineered to handle the massive megafauna of the tundra. The physical colossus. Physically, this predator functions as a colossus capable of reaching a maximum body mass of 800 kilograms, making it directly comparable to the largest prehistoric bears. To maintain agility at this scale, a significant portion of their mass is redistributed away from the limbs and shifted towards the axial skeleton and core musculature, thereby minimalizing limb inertia. Physics versus physiology. Managing an 800-kilogram frame requires overriding physical constraints described by the square-cube law, which explicitly demonstrates that an animal's volume cubes while its bone surface area only squares. To prevent total skeletal collapse, hyperfelines evolved a honeycombed carbon mineralized bone, which require bone cross-sections to scale positively to be 3.2 times thicker than a standard feline. To offset rotational inertia, they utilize a low center of mass, high rotational torque, and segmented muscular attachments. Consequently, this enables a tight turn radius of just 1.5 times their body length. Structural flexibility. Evaluating their spinal biomechanics, hyperfelines possess 24% more vertebral articulations than modern leopards. This specific structural modification establishes that hyperflexibility required to coil their massive bodies tightly before an ambush. Furthermore, the interface between the thoracic and lumbar vertebrae acts as a natural torsion spring, storing potential kinetic energy during the loading phase of a jump, a trait highly consistent with explosive ambush tactics. The physics of muscle. Their muscular system exemplifies mechanical leverage across three core areas. First, they utilize pannate muscle fibers arranged at acute angles, which maximizes the force generation per unit of volume, converting the limbs into high-tension pistons. Second, their tendons are reinforced with specialized proteins that store potential energy, providing hyperacceleration from a stationary stance. Third, their torque density is augmented through elongated olecranon processes in the forelimbs, giving them exact leverage needed to wrestle mega-herbivores twice their size. Metabolic energy allocation. The metabolic energy budget constitutes a highly restricted variable with four clear, non-negotiable parameters. A massive 40% is dedicated strictly to thermoregulation to fight constant sub-zero temperatures. 30% goes toward hunting and locomotion, specifically powering high-energy ambush bursts. 20% is allocated for cellular repair to mitigate high-impact skeletal and structural stress, leaving a narrow margin of 10% for an optimal, efficient, resting baseline metabolism. Predatory performance metrics. This data highlights a stark performance disparity when evaluated alongside modern big cats. Hyperfelines achieve a raw strength capacity of 95%, which is statistically superior to the Amur tiger, 65%. Conversely, they retain a flexibility rating of 90%, meaning their agility remains roughly at parity with the highly flexible African leopard's 85%. Ecological benefits. As a keystone species, the hyper-felines' predatory habits correlate directly with local tundra stability. They offer population control by regulating mega-herbivore numbers, which prevents the complete overgrazing of sparse glacial lichens and mosses. Thereby, their hunting patterns drive crucial nutrient cycling, distributing vital biological resources across frozen plains via their carcass remains and waste. Adaptation and success rate. This tracking model maps their overall success rate. The dataset indicates a sharp, continuous upward trend in adaptation efficiency, which suggests that the lineage achieved near-perfect optimization the moment the glacial climate stabilized into a permanent, predictable glacial state. The ecological drawback. However, the assertion of their dominance is complicated by severe ecological liabilities. Their 800-kilogram mass creates immense trophic fragility. Their massive caloric needs mean they risk overhunting slow-reproducing megafauna, which invalidates food web stability. Their specialized thermoregulation also makes them an evolutionary dead end, as a mere 2°C global warming trend would cause them to fatally overheat. Furthermore, they are caught in a severe K-selection trap requiring multi-year gestations and single cub litters, meaning small populations cannot easily recover from genetic bottlenecks or sudden epidemics. Empirical validation. This speculative architecture is not merely anecdotal, it relies on empirical validation metrics to maintain biological plausibility. The positive scaling rules and departure from isometric skeletal scaling, loading are modeled using allometry principles from Buehner. I don't know how to spell that, so sorry. Muscle torque configurations and Pinot force ceilings are corroborated by fiber data from Azizi. I don't know how to spell that either. Finally, their population density decay scales directly from tropic limits established by Carbone. Through this inference-based methodology, we can reach a definitive verdict on how nature engineered the ultimate glacial apex predator. Thank you all for watching. This is my first video, and there's many more to come.